Hi all. Thanks for joining me in this presentation. This is a submission for my AI Machine Learning Product Management course from Duke University. And the topic I have chosen is the land survey using computer vision. So going forward, we following are the topics that we'll be covering: the opportunity evaluation, crisp DM business understanding, solution validation plan, machine learning system designs, and potential risks in production. The solution that I'm considering over here is for the land survey. Uh, Currently, land survey is done using a hybrid approach, which is for uh, people make use of the engineering teams, let's say for telecom companies or water utility companies, infrastructure that has to be laid down in the ground. For that, when the surveys are done, people make use of Google Maps and they go out in the field, make validations of those objects like footpaths, streets, roads, railway crossing, water bodies, trees, etc. All those are analyzed and recorded and they're validated against the Google Map. Now, this whole survey exercise is very time consuming and is error prone. My proposal is to automate that process. So the three criterias for the opportunity evaluation is whether or not there is a problem. So yes, there is a problem because the survey is manual and it makes the results more error prone and a lot of time and cost is gone into it. Can ML help solve the problem? Yes, machine learning can definitely help solve the problem. We can make use of computer vision algorithms to train the model. Users can use mobile phones to capture images and videos and which can be processed to generate more accurate results. Does someone care? Yes, the government organizations and the private organizations that are responsible for laying down the infrastructure, they are definitely concerned with the fragmented approach for how the things are done in the field. And I'm taking a solution for the mobile usage of the mobile phones, but there are other ways also through which the scanning can be done, like drones and cars with mounted cameras. So that's also a possibility. Going forward to our next evaluation criteria, that is for the crisp DM framework and business understanding about the problem. So in the problem statement is in the world of automation, land surveys are still performed manually, which impact the timelines and costs of projects. Target users, the target audience for this solution are project management and engineering departments of government and corporate organizations that are responsible for developing telecom and utilities like electricity, water, sewage infrastructure. Why it matters? It matters because in the process of engineering activities, steps such as land survey becomes bottleneck for the whole delivery system. There are multiple iterations done to get exact information, which introduces further delay in the project and the projects become out of budget. How is it solved today? It's a manual process. Like I mentioned, engineering teams make use of Google Maps to validate the situation on ground. Since it is a manual process, it requires them to validate the objects like train crossings, trees, water bodies, roads, footpaths, cycle tracks, etc., with their own eyes and as shown on the Google Maps. So they cross-validate that information. What are the gaps in the current state? The process is time-consuming and error-prone due to human dependency. So this is the business understanding criteria. Then defining the success for the solution. The business impact is that automating the process of land survey with the help of computer vision model that will enable quick scans and exact scans can considerably help in reducing the time and cost that is required. For example, a stretch of 1 kilometer that needs to be surveyed, if done manually, can take up to hours, can be like even 1% day, more than around 8 hours or more than that. Whereas AI-based solution, the same work can be done in minutes, or at least, if I have to say, it can be done in less than an hour. What are the constraints for this solution? Well, there is a need of high resolution images, retraining the staff, which means engineering department staff needs to be retrained on usage of this solution. And and high cost of infrastructure for data processing and transfer. So our machine learning model will require a lot of computational power, a lot of GPUs, and so it would be an expensive affair. The outcome metrics I have defined as gain in operational efficiency, cost reduction, and delivery time reduction. And output metrics is processing time. So the data, what is the processing time for that data? Because there will be images and videos, so that needs to be processed. Accuracy of the data captured, so whether or not the objects that have been identified through our machine learning program algorithm are valid objects. So it shouldn't be the case that an actual tree is identified as some other object, whereas tree on a signboard is identified as an actual tree object. So those kind of things shouldn't happen. Then, and the number of surveys that are completed. The success targets defined would be the user adoption and error rate. So more number of users should adopt to this process, and the error rate should be controlled. So let's say the acceptable error rate would be less than 5% in the entire processing of the data. Moving forward, the factor identification, the factors that will have some impact on the process would be the data understanding. So in data understanding, again, the data quality, the data sources, and analysis of data, we need to have a proper understanding of what we are trying to scan, what we are trying to analyze. And the preparation of data is next, which means data cleaning and data transformation. So there can be some wrong images as well. There can be some incorrect information. There can be some low quality information in those images. But then all of that needs to be prepared and cleansed properly before the transformation is applied on those images. Moving next, the validation plan. So the description of solution I've provided on the slide. So it says the proposed solution is a mobile-based land survey tool that utilizes machine learning to automate the verification of engineering tasks, particularly land survey for infrastructure projects in telecom and utilities. And it's the same thing that we have been discussing till now. Defining the success metrics and baselines. Uh, Accuracy of machine learning model is the primal importance, the percentage of correctly identified and validated features in images and videos, the processing time that is required, the average time taken to analyze and provide feedback of each survey, user adoption rate, the percentage of engineers using mobile apps for survey within a set time of frame, the error rate, the percentage of errors, like I mentioned, it should be less, up to 5% or even lesser, depends on how the matrices are defined. Then the data collection and pre-processing is of importance. So do we have the initial data, or we'll be collecting the data as we go? So are we going to make use of any pre-trained models? And the model development and initial testing. So we will have to choose an appropriate model like CNN for image and video analysis. Initial training would be done on the labeled data set using portion of the data for training, and test for the and rest for the validation, like the 80-20% split that we have. And baseline evaluate the model's performance on the validation set baseline matrices for accuracy, processing time, and error rate. Moving next, the validation experiment would be the hyper parameter tuning. Another experiment can be data augmentation and enrichment. Next can be a transfer learning. So we boost the accuracy and cut down training time by using pre-trained models. In the transfer learning, real world testing would be when we test the model in real world conditions to ensure its practical effectiveness. So this happens with the inclusion of the end users. So end users will start making use of the application, and that is when we see how the performance of the model is. Moving to the next slide, the ML design decisions is whether we make use of the cloud or the edge technology. So here the edge computing is more handy because since the engineers will be capturing images and videos in the field, the need for immediate feedback is critical. So that is why we have to make use of the edge computing, and the advantages is low latency, reduced bandwidth usage, increased privacy, and device capabilities. So whatever capabilities the device will offer, we can make immediate use of that, like creating videos, etc. Offline learning versus online learning. Offline learning, this would be offline learning because it's suitable because the model can be trained on a large high quality data set collected over a period of time, and then periodic updates and retraining can be done with the accumulated data to ensure the model remains accurate and up to date. Next is batch predictions versus online predictions. So in this case, we are going to make use of the online predictions because engineers need immediate feedback on their surveys to validate the installations or surveys on the site. Online predictions to ensure that the analysis is done in real time. I'm quickly skipping through the slides. Pardon me for that because I've shot over 5 minutes for this video. So lastly, it's the risks in production. The potential risks in production are the training serving skew. So we can see that there may be a potential skew in the data after the training once the system goes into production. So it can be the case that the system was designed and trained on a set of low quality images, but when the system goes into production, or it can be the other way around, the system was trained on high quality images, but when the system goes into production, users are making of low quality cameras, which is creating low quality images, and then there is a problem, or the lighting is not correct, or the angle is not correct, which can create problems in the results that are expected from the machine learning program. So latency can be another thing which refers to the delay between capturing of image or video and recovering the model's feedback. So latency can also be another issue. So this basically brings me to the end of my presentation. Thank you very much.